Hello. Hi guys, good morning. Welcome back to a new video. In this video, we will maximum palindrome after operations, and this video is going to teach you something which Sandeep Maheshwari or any other motivational speaker have never ever taught you. Let's see. What do I say? That's why I'm smiling. Cool. You are given a zero indexed string array words which have a length of n and containing n zero indexed strings. So just says that okay, I have n words and basically each word is a string like this. Okay, great. Now I'm allowed to perform the following operations any number of times. So there's no restrictions on the operation which I can perform. That's it. The operation is that, as you know, that I will have n words. Now for those n words, I can choose any two words, which means any two indexes I and j, and out of those words, okay, like word I and word j, I can again choose any indexes in those corresponding word, which means x and y. Again, indexes on those corresponding words, I can choose x and y, and then I can swap them, which means ultimately I will be swapping word of ix and word of jy, and again that was any index I and j, and on those indexes I and j, any indexes x and y I can choose. So it's a complete liberty for me to choose any of x and y if I just look in the greater sense. So one thing is for sure, I can replace, which means okay, then I can just simply swap them. So I can choose, which indirectly says one thing, in this entire array of strings or vector of strings, I can choose any two characters and swap them. Thus its position does not matter. So basically I can bring any character anywhere. If I can bring any character anywhere, so for sure its position in the array right now does not matter, because I can perform this operation any number of times. And that's what happens in real life also, that if someone can bring you anywhere, can apply any operations on top of you, so whatsoever position you have in your life will not matter. So please make sure that you are not influenced by someone so much that they can just do whatsoever they want and can replace you, can take you anywhere whatsoever they want. That was a very bullshit line, but yes, still. So what we have seen so far is that because we can just take any character anywhere, for sure its position does not matter. The only thing which matters is, okay, it is a n. That it what is matters. But why it matters? Because we can see that we have to return an integer denoting maximum number of palindromes. Maximum number of palindromes. What's a palindrome? Palindrome is something which reads same forward and backward. And we have easily seen that, okay, if something reads forwards and backwards, we can have even length palindrome, which means, as you can see, blue needs to be same. These needs to be same characters. Oh, same characters, which means character is important. So being a n is important, because if n again is coming again, then I can say, oh, I can make a pair of these two n's. These two n's I can make a pair. So for sure n matters, but n location will not matter for me, because I can bring that n anywhere whatsoever I want. And the same way for a odd length palindrome, I will have even pairs. In the end, whatsoever is the mid element, he can still remain alone. He don't need to have a pair because it's an odd length. Now we want maximum number of such palindromes which we can have. So for sure, if we take the same example which we have taken, we have seen we only are concerned about the characters, right? And this entire thing is the palindromes I have to make. So what I did was, I knew the position does not matter for me. It does not matter for me. So what I did was, I grabbed all of these characters at one place and put in, okay, a, how many times it is occurring? 2 times it is occurring. Again, you can also keep a, all that stuff, but I just want, I just know one thing, okay, I have 26 characters, right? So I know one thing for sure. Again, any number of characters you want, you can have it. It's not specifically required for 26 characters. It's just that I know, I just want that character. Oh, I need to have a pair for him. Which means I need to know the count of that specific character. That's it. I don't need to know the location, because location I will myself decide, because I want to make it as a palindrome. So what one obvious thing is, you want to make a palindrome, you have a. So what you will do? Okay, you will place a and a here, right? Okay, A is exhausted. two A's and two A's finished. Next B, you'll simply place one B here. Okay, now it's a palindrome form, right? Okay, great. Now you have one B remaining and one C. Then one B, one C. It's not a palindrome. So by this fact, you would have given the answer as 1. But it is the palindrome you have made. You have made one palindrome. The problem says, return me the maximum number of palindrome which you can make. So for sure, if I just think one step back, and rather than placing, I know I have 2 here. So, okay, 2 A's I had. So I will firstly place, let's say 2 A's. Let's say I firstly place my 2 A's here. Okay. Then I place my B here. As in, I just only wanted to refer one thing. Okay, let's say even if I place my A here. Okay, great, no worries. Then rather than placing a B here, I will place a odd frequency element, because B could have made a pair, but you did one thing. You used B here, thus you snatched one B from his brother. That's not a good thing, right? So whosoever is alone, please pick him first. So as you can see, this location, it desires a alone person, so like me. So what I will do is that I will place a C rather than a B here. So one thing we have seen is that one learning which we saw, although we learned many stuff from this problem, but the first learning is always place the odd frequency character in the middle when the length is odd. When the length is odd, we'll place the odd frequency. Again, odd frequencies which is occurring odd number of times, because if I just even snatch one from him, still the even pair still remains, because for palindrome, pairing is very important. So even should be there for my future purposes. So I will just make sure that one thing. Okay, it's the first learning which we got from this problem. Now, although the problem example itself is not much good, so there we need to do a trial and error to figure out any other edge case remaining or not. Let's take a bigger example. We took, okay, again, I have grabbed the frequency of those elements. Let's say 4, 1, 1, 1, which means B, C, D, and E. Now, like what above learning we had, we'll apply the same learning here itself. Okay, I will place a here, right? Okay, 4A are exhausted. Then, okay, in the middle, I will place an odd frequency element. Okay, I'll place any odd frequency element. Let's say I placed a B here. Okay, B here. Now, for the remaining ones, Aryan with other frequency. Okay, like for the remaining ones, let's imagine that you had a E and a F also. Let's say with a frequency of 1, 1. Right. Okay. Now for the remaining ones, you will have no pair whatsoever. But if I tell you that rather than filling this big length and making that as a palindrome, what if you would have made a smaller length as a palindrome? So rather, if I would have used this A in the smaller length, okay, A is here. If I use this again A, because 2 A's are still remaining, if I use again this A, still it's a palindrome. So here you made 2 palindromes again. For the B here, I don't have any other even number count remaining, so I cannot make the big length as a palindrome. But from here we realize one thing. It's always good to make smaller lengths as a palindrome rather than a bigger length, because my ultimate aim is not to make a big length palindrome. My ultimate aim is to make maximum number of palindromes. So I will utilize my utility. My utility is the frequency of elements. Frequency of the same elements. I want to utilize that in smaller lengths so that I can make more and more number of palindromes. So it's the reason my learning too is that I will always fill smaller lengths first, because I want to get the maximum number of palindromes. So these are the only 2 learnings which we need to solve this problem. That's it. Again, if you have got this, just dry run by yourself and then do code by yourself also. But now we will have a quick dry run of how this will actually solve. First and foremost operation, position for us, it does not matter. So what I will do is I'll grab the frequency of all the characters. Let's say I have got the frequency of all the characters. Now I will go on and try to fill my elements from the bottom, which means from the smallest length to the largest length. So first I will be applying my operations on the smallest length first. But when we say applying an operation, what we mean ultimately, if you saw above, we are only concerned about the frequency of element. Okay, if the frequency is odd, I can place at the odd location. Frequency is even, I can place at the even lengths and stuff. So we are only concerned about if it's odd or even. So what I did was, okay, from this input frequency, I grabbed the even and odd count. so that I can actually generalize, or basically make my code a bit more simple. Again, there are multiple ways to implement this, but I'm just showing you that we can just go very simple, because we saw that we are going greedily from the very smallest length to above length. Both operations, learning 2 is also greedy, learning 1 is also greedy. Both operations are greedy for us. So we just simply go and check, okay, what's the even and what's the odd length count which we can encounter. So frequency was 6, 3, 2 and 3. Now I can just simply say even length will be, okay, how many even pairs I can form with this frequency of 6. I can form 3 even pairs. Okay, 3 is simply frequency by 2. For with this I can form 1 even pair, B and B. For this I can also form 1 even pair, C and C. For this I can also form 1 even pair, which is D and D. Again, remember that fact, because D and D. Aryan, what about other D? Other D will actually go on to its odd, because this odd says I can contribute 1 D as my odd. Here I will have no odd, but 1 D can contribute to my odd itself. So you can simply say that, okay, my even, I will have 6 even pairs which I can form, and 1 odd value I will have. So again, even I should count it as a form of pairs. Make sure, because I want my even to be same. Odd is just because I know odd will always come in the middle, so odd I just want the frequency. So 6 even pairs and 1 odd element I can form. Okay, great. Now let's start building the answer. Again, remember, you have 6 even pairs and 1 odd element. 6 even pairs and 1 odd element you have. You start from the very smallest length. For sure, the length is 1, length is odd. So firstly, exhaust your odd value. Okay, I will not use my even value on the odd element. Again, that's an odd element, which means the length is odd. So middle element, and the middle element is only this element itself. So in that place, an odd frequency element. So I'll grab the odd frequency element, which means whosoever is the odd frequency. So my odd frequency will go to 0, because I have exhausted and used one of the odd frequency element here. Now it has gone to 0. So now my even length is 6, odd length is 0. Now you saw that I will have next. Okay, this is gone, and answer has increased by 1 because I have got 1 as palindrome. Next is my length is 2. So ultimately, like, length is 2, so I will need to have even 1 pair. I need to exhaust my 1 even pair. Do I have 1 even pair? Yeah. Earlier I had 6, so I can use 1 even pair for this specific length. Okay, I'll use 1 even pair, and I will just put even values here. Let's say the same values, same. Again, I'm not writing the actual characters. I'm just writing, okay, it's the same values. Let's write, okay, let's write a right, so as to not confuse you. So now if I have put the even, because I had 6 even pairs, and I only need 1 even pair. So my remaining even pairs are 5, and odd pairs remaining are, like, odd values remaining are 0. Again, answer has been 2 so far. Now, for the next element, okay, its length is also 2. For him also, I need 1 even pair. I have 5 even pairs remaining. I can use 1. Okay, now even pair remaining are 4, and odd values remaining are 0. But my answer has been increased to 3. I have 3 palindromes. Now, next length is a 3. Next length is a 3. Firstly, check, because next length is a 3, which is the odd length. So for sure, 1 value you should keep in the middle. Do you have an odd value? Do you have an odd value right here? If I had an odd value, I would have used that odd value to place in the middle. But right now, I don't have the odd value. What to do in this case? In this case, you will ask, because you know, you have 4 even pairs, which means 4 pairs, 4 even pairs. You would have 4 even pairs like this. So I will say one thing, bro, I need 1 odd frequency element. I need 1 element. Although I would have taken from odd itself, but odd is 0. There is no odd frequency element. So what you can do is, you can give me, so I will ask my even. Even had 4, as you can see, even had 4 pairs. So I will take 1 pair from even, and I will say, okay, now odd you have 2 elements. So I grabbed 1 pair from even, and I said, okay, odd bro, now you have 2 elements. So now odd can use 1 element to place in here. So I will use 1 odd element and 1 even pair for this. So now, as you saw, my even has been reduced to 3 and odd increased to 2, because I borrowed my 2 pair values and passed it as 2 values to my odd. Now I'll use 1 even and 1 odd. So I'll just simply get, okay, out of 3 even and 2 odd, I used 1 odd to place in the middle. So my odd values has reduced to 1, and even values still remains the same. But now I have to also place 2 even values, 2 like one pair of even values, so I'll use one of the even count also. So now my remaining even count is 2 and odd count is 1. But still, another palindrome I have made. Answer has been increased to 4. Now going on last, this is my remaining. Even pair remaining are 2 and odd value remaining are 1. For this I will need one, because you can see odd, like length is odd, so I need to place one value here. I will ask my odd, bro, you have odd value? Yeah, he has odd value, so I'll take from him. And I want 2 even pairs. I have 2 even pairs. Great. So I will just say I have got my answer. My even and odd count reduced to 0, and I will have 5 of my palindromes, and that's how I can simply solve it. Cool. That's simply see the code. It's pretty simple. Firstly, we grabbed the word sizes and we sorted the word size on basis of the increasing order, because we know that we will fill in this. Again, this word sizes is exactly these lengths 1 2 3 1 2 2 3 and 5. So I wanted to sort these word sizes, which means word lengths, in the increasing order. So I just did that. But remember, I want the frequency of the characters and not the characters itself. So I took an unordered map and got the frequency of all the characters which I wanted. Now, when I have got this, you know one thing, I want to know the even and the odd count. So I'll go on in my frequency vector which I have grabbed. Even count will be simply count by 2, because I want the even pair count, and odd is nothing but odd element count. That I'll simply grab it. I have now even and odd count. Now comes my main function. In this, if my length is odd, because you saw, if my length is odd, if I have odd count, I will grab that odd count and place in the middle. But if my length is odd, and if I don't have an odd count, so I have to borrow from my even. So I will reduce my even, I'll increase my odd. But Aryan, you increase the odd by 2 value, right? Yeah, I'll increase the odd by 2 value, but then I will also have to reduce it, because I will have to put it in the middle, one odd value, as we did here, right? So this will actually become my odd plus plus itself, which means here I did a odd plus equal to 2, I did a odd minus equal to 1, so this will become a odd plus plus itself. So if my length is odd, I will either grab my odd frequency element 1. If I don't have it, I'll borrow 2 elements from my even pair and can take one odd element from that. So I will remain like this. Okay, but now what about the even? What about the odd, like remaining elements? Simply, if your even count is less than the word size by 2, which means you cannot place these number of even pairs, simply break. But if you can, then simply increase the answer and also reduce your even pairs by this length by 2, which you have put in these number of even pairs at this specific location, and ultimately return the answer. Now your time, if you consider that you have n words and each word was of length m, then your time will be nothing but, as you know, that you sorted the word lengths, which is n log n, and also you went on to all the characters to know the frequency of those characters. So it is nothing but O of n into m. So in worst case, it is O of n into m time complexity, which is 1000 into 100, right? Space, again same, you use the word to store in the, you made a new vector to store the word itself, so that will be O of n itself for like the word's length, right? And 26 for the frequency, which means the unordered map which you have taken. So this will be time and space only for you. Cool, like I was watching, see you, bye, take care.